Hey guys, I'm Jose and welcome to this new tutorial on Unity. So we're going to start a series of 3 tutorials, I think it's going to be, for building a cellular automata and see a little bit of arrays, 2-dimensional arrays, some GUI interface elements, and also the cellular automata calculation. So let's get started, right? I'm starting with this kind of clean scene with a plane and a directional light. Let's go ahead and just create a camera as well, because I deleted the main one. So let's just place it somewhere where we could see our space here, maybe -90 there, just looking down a little bit, like so, right? So very simple, and let's go ahead also and create a new game object. That's going to be a cube. Let's press F to frame into that object, and we're going to go into our scripts folder and create a new script, JavaScript, that we're going to call it CA cube, right? And let's drag this script to the cube, right? So basically we have this script inside the cube. Let's go ahead and edit it. And we're here in this simple script. So we're going to try to give this cube is going to be our prefab. So we're going to try to just give it some properties. So let's go ahead and do a variable called type. We're going to type integer. That's going to be 0, right? Basically this type is going to determine the color of the object, and also, well, the state of the CA, right? But for now, we're going to just look at it changing color. So let's do something like if type equals 0, right? So if it's 0, let's do something like render dot material equals, sorry, dot color equals color dot, we could say black, right? So we have the black cube, it's the type is 0, and if we can just copy basically this stuff here, and if the type is 1, the material could be white, right? So let's save that. Let's go into Unity and play our scene. So you see that our cube is black, and we have the variable here. So if we change that to 1, it should change to black, 0, and 1, right? So we have that working. You can also just go here and it should work as well, right? Pretty handy to just come into the scene mode and see your script running, not only working in game mode, because we can still kind of just change things and move things around, right? So that's good. Let's create a prefab out of this guy. So let's create a new prefab. So we're gonna call it CA cube, same name, and let's drag the cube into our prefab, right? So now we have this prefab here. We can actually get rid of the original one, right? So that's the first thing, to just create a prefab with a type entry in the script, right? So the second thing is gonna create an empty game object that is gonna be the CA. So let's call this element CA grid, right? So let's call it CA grid. So we have here, it's an empty game object, and we are gonna create another script for this element that is gonna be create JavaScript, and we're gonna call it CA grid, or basically we could call it CA, just because this is going to be the main calculation of the CA, right? We could drag this into the game object, right? So that's the object. So it seems like it's not allowing me to, so we can just go here into script, CA script. Oops, not that one. or we can go here like that. Alright, it seems that I'm having a problem here just because I've named another script previously CA. So let's go CA calculation. There we go. I was preparing the tutorial previously, so there might have been some conflict there. So okay, we have the script CA calculation inside our empty object, right? So basically, this empty object, it's gonna create a series of instances of the cube first and assign random values. This is gonna be what we're trying to do, at least to start with, right? So let's go ahead into our CA calculation, edit script. And what we have to do here is first define the variable, the object that we're going to be working with. Right, so we're going to drag and drop the prefab into our game object here. And with that, we could actually start working with instantiation. But we also want to create a variable called grid that is going to be a game object array. But because we want to do a grid, we're going to do a two-dimensional array, and that's the way to actually define that it's this array is going to be two-dimensional, right? So in the start function, this is where we want to actually create the CA. Let's start by creating a for loop. So variable x from type int equals 0, x smaller than maybe 20 for now, and x plus plus, right? So this is our for loop to create a series of instantiations. And now we want to do, because this is a grid, we want to do a double for loop, right? So let's do that. And let's say this is going to be y. Let's make sure that we're not running into any problems yet. It seems that we're not. And basically, for instantiating the game object, we need a few pieces of information, right? So we need the position, a vector position, we need a rotation, and we need the game object to instantiate. So let's define a variable called position from the type vector3, right? And this guy is gonna be here. We're gonna use x, comma 0 in y and comma y in the z. Just because Unity uses the y facing up, I'm gonna use the my grid is gonna be in the x and the z. So I'm going to just put the variable I here. I could have just named it set, but for now it's fine. The next variable we need for the instantiation is variable rotation from the type quaternion. And this one will be the quaternion identity. Oops. I don't think that's capitalized. There we go. We could always check if we're not getting any errors. It seems that we're not. It's fine. And now we have to instantiate. So we will say the variable new object from the type game object equals instantiate. So we want to instantiate this object, the game object that we will define outside the script, in the position with that rotation, right? Obviously, there's a few things that we could change here. But let's see if we could now, having this slot for the game object, we could go into our prefab folder and drag and drop our prefab. right? So let's see if we get anything here. And you see that we have basically created a series of cubes, right? If we go into our scene mode, we could actually pick them, and you'll see that each cube is one unit, and they're all packed together, right? And they're all with a type 0. That is the default type to start with, right? So that's good. There's a few things that I would like to kind of add here, right? Just to make this a bit more flexible. So one of the things that I want to do is just say I want to deal with the variable columns from the type int equals 20, and the variable rows also from the type int equals 20. And this is basically for allowing this script to be a bit more flexible in terms of the creation of that grid, right? So we can put these variables here, and this is the loop is going to basically go till columns and till rows, and this is going to represent in a way how big that grid is going to be, right? Something else that I might need, depending on the geometry right now, because those cubes are one unit, they seem to be working fine, but I could do a variable spacing. Spacing from the type float, and I'm gonna leave it in 1. I could just put something like 1.2 to just show you the difference, but if we multiply x times the spacing and y times the spacing, we could see that we could actually create a separation between the cubes, right? So now the grid is some multiplier, so to kind of spread them apart a little bit. But yeah, it could be useful. We could just go back to 1 and they should be packed, right? If you change these values of columns and rows, the grid is not going to change. Just remember that we are actually doing this script still in the start function, right? So this is calculated once at the beginning, and then it doesn't really create or basically doesn't update our grid condition. So that's good. One of the few things that we want to start doing here, it's first of all, we want to just make sure that these new objects, for instance, one of the things that we want is just for them to be children of the CA object, the CA grid object. So in a way that they don't populate this area here massively, but just like live inside this object. So that's something that we could do quite easily. So new game object dot transform dot parent, right, equals game object dot parent, and I think, sorry, game object dot transform. There we go. So this game object's parent is this game object's transform. So let's see if that works actually. Yeah, and you see that we have this list of, in this case, 400 objects, but they are living inside the cube, the CA grid element, right? So that's good. And the main thing really is just to start a kind of calculation of the CA, is that we have to kind of go inside this new instance, the new object, and basically change the type, right? Access this information and decide that we want to start with maybe a random value, right? So we're going to say something like new object dot get component, and we're going to call the component CA cube, right? And in this way we're actually invoking this script, right? So we're basically opening that script with the dot operator. We can actually access any of these global variables. In this case, the only one is type, so dot type equals random dot range from 0 to 2. And this is just a quick way of saying this will result in 0 or 1, like for the most part, because it's not, I'm not using floating points, so it's going to be integers between 0 and 1, right? And 0 and 2, but 2 shouldn't happen too much. So Let's see if this is actually happening. We're running, right, so there we go. We have the grid being created and assigning random values, so we can just go a bit bigger. Obviously, depending on how big the grid you have, your calculation will, your frame rate might just drop, right? But in my case, it's running pretty good. So this is the first stage of this tutorial, how we see how to use the grid and the array. Well, one of the things that we might still introduce is that we're not using the array yet, so we could say array x comma y equals new object, right? This won't make any difference right now, but the moment that we really want to start doing calculations for a CA, we will need these variables, basically the structure of the array, in order to kind of ask who is the neighbor, right? So that's going to be quite important. Maybe just to finish this, maybe we can convert all this bit here into a function. So we could say function create cubes or create grid, and we can actually cut and paste this part here over here, right? So just to make sure that everything is nice and neat. There we go. And we can save this. We will have to call the grid function for sure here. So that's the first step. Let's make sure that it's working. Well, it's not. So we're having a problem in number 32. Right. We're having a problem in this line. We haven't initialized the array, right? So we can also do that in the function. So we do grid equals new game object array x comma y, right? So let's see. Sorry, this is columns and rows. So this is describing the size of the array, right? So we initialize the array by determining this is the size that the array is going to have, right? So there we go, right? So we're actually creating the instantiation before we do it quite straightforward way, just without any structure. But then when we create a structure, which is the array, we initialize the array and we pass the information of that new instance into the array. So we can actually ask questions like, is my left neighbor on or off, or basically which is the type that he has, right? That would be crucial to actually deal with the CA. So that's it for now. And in the next one, we're going to start seeing how to create somehow of a graphic interface for this game of life. See you soon.